Welcome to Gridlock, Engineering for the Real World. I'm Dr. Paul Moses, an electrical engineer, educator, and researcher based in Oklahoma. Every time you switch on a light, charge an electric vehicle, or use an appliance, we're relying on an incredibly complex system that most people never think about. Behind every reliable source of electricity are difficult engineering decisions, economic realities, technological innovation, and public policy, all balancing competing priorities. This podcast is about those real-world trade-offs. In each episode, I'll be joined by leading experts from across engineering, energy, government, industry, and academia to discuss the challenges shaping our energy future. We'll explore topics such as grid reliability and resilience, affordability, infrastructure modernization, renewable energy integration, nuclear power, cybersecurity, and many other technologies that will define tomorrow's electric grid. Our conversations begin here in Oklahoma, but we'll also examine national policy, international developments, and the global engineering challenges facing modern power systems. Whether you're an engineer, student, utility professional, policymaker, researcher, or someone just curious about how our world is powered, this podcast is designed to bring thoughtful, evidence-based conversations to the forefront. We'll move beyond headlines and explore what really works, what doesn't, and why engineering decisions matter. Thank you for joining me as we explore technologies, ideas, and people building the future of energy. I'm Dr. Paul Moses, and this is Gridlock, Engineering for the Real World. Hi, today I'm outside my house near my electrical panel, and behind it, you see a smart meter. In Oklahoma, most of the houses have smart meters. Some other states are trying to catch up. But smart meters have rolled out since the 2000s and 2010s, and they were a key element of intelligent smart grids. So not only do they provide the utility with greater granularity into your electrical consumption, traditionally, you may remember the spinning kilowatt-hour meters that have been used for over 100 years, where the meter man would come once every month or so and get your usage for that month. And that's the only data the utility had. Nowadays, these smart meters can communicate and send that data every few minutes and get your near real-time consumption. And even you as a customer, some utilities allow you to log into your payment portal for that utility and access this smart meter data. Most people don't. And you can actually see in greater depth how your usage varies throughout the day for hour by hour or even several minutes at a time, down to the minute accuracy. And also, smart meters provide the utility with greater outage data, so they can quickly identify outages and repair. And they eliminated the meter man. So there were a lot of benefits to the utilities. But when smart meters rolled out, it had a greater vision to allow the customer to have a greater involvement in the energy marketing in terms of using your smart appliances, so-called smart appliances. They envisaged that the utility could control some of your appliances when the grid is in a bind. If you imagine the power lines are like an energy superhighway, in certain times of the day, that highway gets full, or the power lines get overloaded or near capacity, then the utility conceivably could go in and remotely control your loads, at least the loads that you can defer, and for example, your dishwasher, your clothes dryer, and move them off peak and reduce that peak. And that was supposed to help reduce the pressure to upgrade their infrastructure, their costly infrastructure. To some extent, we have that. We don't have utility control over our appliances, but we as customers can control our appliances with our smartphones, smart switches, and program them to turn on at a later date or later time of the day. However, smart grids were envisaged to be more than that. There was supposed to be much more interaction between the customer and the utility. And in this panel, you see this is a standard electrical panel with your circuit breakers that you find in most of North America. You can upgrade these panels to have smart metering and smart circuit breakers, and you can monitor exactly how much energy and power each circuit is using. But to do that, it would cost several thousands of dollars to get an electrician and all the equipment to upgrade that. Most people don't do that. But we have that ability to do that if we wanted to. And then that would allow you to fine tune and tie into smart home area networks or home automation and optimize usage. But we don't do that. So typically, we wait till the end of the month, see our electricity bill, and then pay it. And then some of us who are a little bit more inclined, like I am, I don't turn on my heavy appliances until off peak after 7 p.m. And then that, for the sake of reducing my electricity bill, I try to do that. But smart grids were supposed to go further than that. For example, these air conditioner units, many of them use variable speed technology. Instead of running at full speed, most air conditioners run at 100%, and then they cycle off to 0, 100, 0, 100, according to your thermostat. And then there are some AC units that can power down not just to 0, but down to 50%, 70. We have that full range. We call that variable speed compressors. And some of the ideas that the community, the engineering community have been talking about and piloted is the utility being able to control your compressor on your air conditioner on a hot day when the grid is in a bind, that highway is congested. The utility can go in and dial down your AC down to maybe 50% for a few minutes each day or each hour. And that would really help them. Imagine that being done not for just one house, but millions of houses and shopping centers. If the utility have that flexible load, they can power down, reward you for that inconvenience. But for air conditioning, powering down to 50% for a few minutes out of an hour won't affect your temperature inside your house because of the temperature doesn't change that rapidly. We have a large thermal mass or inertia so that the temperature in your house is pretty slow to change. So you can power down your AC temporarily and your temperature in your house won't change if it's only temporary. But we don't exploit this. It's not yet mainstream for the utility to control your appliances in this manner. Also, your refrigerator could do the same thing. The utility could control your refrigerator and dial down the compressor if the grid is in a bind, reward you for that. And that's what we call flexibility provision. And so those are the kind of capabilities that were initially conceived when smart meters and smart grids were to roll out, not just for the utility to have greater granularity into your usage, but you as a customer to have more insight in how you use your energy and to be able to respond to pricing signals. That was another thing. The utility could you could have a pricing signal. The energy is costly at a certain time of the day. Your appliances could use that information to optimize their use later. We've been working on algorithms like that for smart appliances, electric vehicle charging, responding to grid conditions, and also your customer priority and needs, and optimize usage so that the grid is satisfied in its operation and you as a customer are getting what you need. Those algorithms are out there, they're published and open source and whatnot, and they're very easy to implement these days on very low cost microcontrollers, less than $20 or so chips that can do all this. But we don't do it. So where is that gap? We still use our electricity much like we did 20 years ago before smart grids. And how do we bridge that gap so we have greater functionality as a customer in embracing smart grid technology? There are privacy concerns, legitimately, that if you have these smart meters and you have greater data on your energy usage, that could be exploited for nefarious reasons. People may know you're not at home if your energy usage is down or you're not using these appliances. How do we protect against that? That comes under cybersecurity. So there are legitimate concerns. Anyway, we will have a series of discussions with professionals and talk about some of these challenges moving forward and how our grids can be truly modernized and beneficial to not just the utility, but the customer, and keep costs low. So thank you for listening, and we hope to have more discussions in the future.